Picture this. You're walking across Earth, not today, but 50,000 years ago, and as you travel, you start noticing something strange. You encounter people, but they're not quite like you. Some are shorter, built like they were carved from rock, thick bones, wide chests, brows that jut out like a shelf. Others are tall and lean, adapted for long days moving across open plains. And somewhere on a remote island, there's a group so small, so unexpected, that if you didn't know better, you'd think evolution was playing a joke. These were real people, real humans, just not us. Today, if you ask someone what a human looks like, they picture us, Homo sapiens. But for most of our planet's history, human wasn't one answer. It was a whole collection of answers. Evolution didn't build us once and call it done. It kept experimenting. Different bodies, different brain sizes, different strategies for surviving the same brutal, unpredictable world. And then, one by one, those experiments ended. Today, we are the only human species left on Earth, not because we were the strongest, not because we were the oldest, not even because we were the most resilient, just because we're still here and they're not. So what actually happened to the others? Let's start with the one most people forget, Homo erectus. If you judged success by how long a species lasts, Homo erectus wins. They appeared roughly 2 million years ago, long before us, and they survived for over 1 million years. To put that in perspective, our entire species, Homo sapiens, has only existed for around 300,000 years. Homo erectus outlasted us several times over, and they're gone. Their bodies were surprisingly modern, long legs built for endurance, shorter arms than earlier relatives, a frame designed for walking and running across open ground. They were likely among the first humans to leave Africa entirely, spreading into Asia and adapting to environments our earlier ancestors never reached. They made stone tools, they hunted and scavenged, they figured out how to live in wildly different climates across enormous distances. For a long time, a very long time, that was enough. The last known Homo erectus fossils were found on the Indonesian island of Java at a site called Nandon. The best current dating puts them at somewhere between 108,000 and 117,000 years ago. By then, the climate had shifted, forests had expanded and collapsed, rivers had changed course, and other human species had entered the picture. And Homo erectus, after surviving longer than almost any human group in history, quietly disappeared. We don't know exactly why. Isolated populations, shrinking resources, competition from newer species, maybe all of it at once, but their story leaves behind one uncomfortable truth. Lasting a long time doesn't mean lasting forever. Now let's talk about the Neanderthals, the ones people think they know. For decades, they were portrayed as brutish, dim, barely human, grunting cave people who got outcompeted by smarter, faster Homo sapiens. That picture is almost entirely wrong. Neanderthals were not a failed version of us. They were a different version of what a human could be. Specifically, they were the answer to a very hard question. How do you survive an ice age? Their bodies reflect that challenge. They were stocky and powerful, wide rib cages, thick bones, strong arms. Their large nasal passages are thought to have helped warm cold air before it reached their lungs. They were built to retain heat in environments that would have been genuinely deadly for an unprepared person. They hunted large animals, up close. The kinds of injuries found on Neanderthal skeletons look similar to injuries on modern rodeo athletes, fractures and trauma from coming into direct contact with large, dangerous animals. This wasn't passive scavenging. They were active, coordinated hunters. Beyond survival, evidence suggests Neanderthals buried their dead. They used pigments, possibly for body decoration. They cared for group members who were sick or injured. We found skeletons of individuals who survived serious injuries that would have been impossible to recover from without help. They weren't just surviving, they had something that looked like culture. For hundreds of thousands of years, they held their ground. Then, Homo sapiens began moving into their territory. After around 40,000 years ago, Neanderthals vanished from the fossil record. Not gradually fading, just gone. So did we kill them? The honest answer is, probably not in any direct, dramatic way. The real story is messier and in some ways sadder. Neanderthals lived in small, scattered groups, and small populations are fragile. One harsh winter, one disease passing through a community, a birth rate just slightly too low for just slightly too long. Ancient DNA analysis shows that some late Neanderthal groups had very limited genetic diversity, a sign that their numbers were already dangerously thin before Homo sapiens became a serious presence. Meanwhile, the climate kept shifting. Warm periods gave way to cold ones. Familiar prey animals moved or disappeared. Forests expanded where grasslands used to be. The world these people understood kept rearranging itself. And then, into that already strained world, came us, a species with broader social networks, longer distance trade and communication, and what appears to have been a faster rate of cultural change. Not necessarily stronger or smarter in every single way, but more adaptable in the ways that mattered most when the environment was unstable. There's also something that complicates the story entirely. We didn't just replace Neanderthals, we mixed with them. Most people with ancestry outside of sub-Saharan Africa carry somewhere between 1 and 4% Neanderthal DNA. They didn't disappear without a trace. Some of them became part of us, but as a distinct, living human species, they were gone. Then there are the Denisovans, and they are perhaps the strangest chapter in this story. With Neanderthals, we have skulls, tools, bones, burial sites. With Denisovans, the entire discovery began with a fragment of a finger bone found in a Siberian cave called Denisova. A single finger bone. It was small enough that it barely looked significant, but when scientists extracted and analyzed its DNA, they found something that rewrote our understanding of human history. This wasn't a Neanderthal, it wasn't a Homo sapiens, it was something else entirely, a previously unknown human group discovered not through fossils but through ancient genetic code. Since then, the physical evidence has remained frustratingly sparse. A few teeth, a jaw fragment, a handful of additional bone pieces. For years, researchers couldn't even reconstruct what a Denisovan face looked like. Their physical form was largely a mystery, and yet their genetic reach was enormous. Denisovan ancestry shows up in modern populations across Oceania and parts of Southeast Asia. Sometimes at levels higher than Neanderthal ancestry appears in other groups. More remarkably, Tibetan people carry a version of a gene called EPAS1 that helps the body function efficiently at high altitude, and that gene appears to have come, ultimately, from Denisovan-related ancestors. Think about what that means. A human species that vanished tens of thousands of years ago may still be helping people breathe today at 14,000 feet. The youngest confirmed Denisovan remains are around 40,000 years old. Some genetic analysis suggests isolated populations may have persisted until around 30,000 years ago. After that, they fade out of the record entirely. Why? We genuinely don't know. Their range may have been vast, from Siberia to Southeast Asia, but their population may have been spread thin. Climate change may have fractured their habitats. Contact with incoming Homo sapiens groups may have meant absorption in some places and displacement in others. We simply lack the fossils to know for certain. The Denisovans leave behind a strange kind of grief, an entire human species, wide-ranging and genetically influential, reduced in the fossil record to a finger bone and a few fragments. Not cities, not art we can point to, not stories anyone remembers, just DNA, scattered quietly into the populations of people still living today. And then there's Homo Floresiensis, the one that still feels almost impossible. On the Indonesian island of Flores, archaeologists excavating a cave called Liang Bua uncovered the remains of a human being unlike anything previously described. Standing around a meter tall, with a brain roughly the size of a chimpanzee's, this was clearly not a modern human. The media called them hobbits. The name stuck. Initial skeptics argued they must have been modern humans with a pathological condition. The brain was too small, the body too tiny. Surely this couldn't be a real, distinct species. But the evidence held up. Homo floresiensis was real, a separate human lineage that had been living on Flores for a very long time, evolving in isolation from the rest of the human family. What happened to them physically is something called island dwarfism. It's a well-documented evolutionary pattern. When large animals end up isolated on islands with limited food resources and few predators, they tend to shrink over generations. The island becomes its own selective pressure, rewarding smaller bodies that need fewer calories. Homo floresiensis may represent one of the most extreme examples of this process in human evolution. And they weren't helpless. They made stone tools. They survived alongside Komodo dragons, giant storks, and a dwarf elephant species called stegodon. They navigated an ecosystem that would strike most modern people as genuinely nightmarish. The fossils at Liang Bua are dated to between roughly 60,000 and 100,000 years ago. Stone tools associated with them may extend to around 50,000 years ago, and around that same period, Homo sapiens were moving through the broader region. Then Homo Floresiensis was gone. Volcanic activity on the island may have disrupted their environment. Their prey animals may have declined. Modern humans may have added competitive pressure. On an island, the math is unforgiving. A small population doesn't need a global catastrophe. A chain of local problems, arriving faster than a small group can recover from, is enough. An entire species that evolved over hundreds of thousands of years, adapted to one specific island, surviving creatures that would terrify us, erased. So why did we make it? This is the part of the story that's easy to get wrong. The tempting answer is, we were smarter, we were better, we won because we deserved to. But that answer doesn't survive contact with the evidence. Neanderthals were intelligent. Their brains were, on average, as large as ours. Denisovans adapted to some of the most extreme environments on Earth. Homo erectus outlasted every other human species by a wide margin. Homo Floresiensis built tools and survived conditions that would overwhelm a modern person. So if intelligence isn't the answer, what is? The current leading idea is something less dramatic but more interesting: connection. Homo sapiens appear to have been exceptionally good at building and maintaining large social networks, not just immediate family groups, not just small bands of a few dozen people, wider webs, groups connected to other groups, sharing tools, sharing information, trading materials across long distances. This matters because it changes what a failure costs. If one group collapses, another group carries the knowledge. If one region becomes uninhabitable, people can move toward other groups who will absorb them. If someone solves a new problem, the solution spreads. Ideas don't get trapped and lost in one isolated valley. Other human species may have had culture, but Homo sapiens may have built culture that moved faster, traveled farther, and connected more people. And when the planet became unstable, when climate shifted and food sources moved and environments transformed, a connected species could absorb those shocks in ways that isolated populations simply couldn't. But we shouldn't make this too clean either. Luck was real, geography mattered, population size mattered, timing mattered. Maybe we survived partly because of our social architecture, and partly because, at a few critical moments, we happened to be in the right places with the right numbers. The other humans were not our ancestors. They were not practice runs. They were not stepping stones to something better. They were complete answers to the question of how to be human, just different ones than ours. Homo erectus, who walked this planet for over 1 million years. Neanderthals, who survived ice ages that would end civilizations. Denisovans, who left behind almost nothing except the genes still helping people breathe in thin mountain air. Homo Floresiensis, small and remarkable, living out their entire world on one island. They're all gone now, and we're what's left, not the peak of anything, not the inevitable outcome of some grand biological plan, just the last branch on a tree that used to be full of life. If the story of the other humans teaches us anything, it might be this: extinction doesn't only come for the weak, it comes for the isolated, the unlucky, the specialized, the ones who couldn't adapt fast enough to a world that changed faster than they could follow. We survived, so far. Whether we've actually learned anything from the ones we outlasted, that part is still being written.